All right, we should be live. Welcome everybody to another live stream repair. We've got our work cut out for ourselves today. We've got 3 HomePods that were mailed in today, and 2 of them have the pretty common no power issue. I'll go ahead and just take a guess now that they've both got shorted diodes on the amplifier. And we've got a 3rd HomePod that has no base, and that one with no base was previously sent in, and I had already fixed it up. And when I sent it back to them and they got it, they reported that it didn't have any base. So it'll be interesting to dig into that one and see if perhaps I missed something or made any mistakes. And so yeah, let's just jump right on into this now. So first one we've got here is from Alex, and I'm abbreviating people's names, for a couple of reasons. One, kind of makes it a little more anonymous, and 2, honestly, I can't pronounce half of these names. And I mean, if you knew what my last name was, you would. Well, anyways, so let's go ahead and tear into this one. So actually, before we do that, really quick, let's just sanity check that this one indeed has no power here, because we don't want to do all this work just to find out that there was a misunderstanding here. So, alright. No signs of life when I plug it in and tap on it. And my watt meter here says that we're pulling about 6 watts from the wall. So, pretty typical signs of a shorted diode on the amplifier here. But go ahead and pull that power cable off and start tearing this HomePod apart. To do that, let's go ahead and get our spudger here and just stick that under the top plastic cover here, and then we'll work that all the way around to cut that adhesive loose and pull this plastic layer off. That'll reveal a couple of screws underneath that we can start working at to tear into this a little more. Alright, just like that. Got that off without a problem. So we'll get our T6 screwdriver. Butterfingers today. And let's go ahead and take these screws out for the display. These are, well, maybe I've gotten used to it, but these are pretty easy to work on, having just one size screwdriver to worry about. Alright, so when we get those screws out, we're going to go in and pry this display up. We want to make sure we're getting under both layers for that display there, and that we're not separating the plastic from this PCB, this display PCB here. We want to pull this up as a single unit. So we'll start by wedging our metal tool in there, and then we're going to grab a plastic one and wedge that underneath, and then we can pull the metal one out and use our plastic tool to go around that display here and peel that off. The reason why I like to use the plastic tool here instead of the metal one is a few reasons. Pretty much just to avoid doing any unnecessary damage to the plastic frame underneath, or scratching and cutting into the PCB for the display that we're prying up here. So plastic is always a little more forgiving. And there we go. Got the display out. Let's just put that adhesive back down so we don't have to go back and do that later. Alright, good enough. Get our T6 again and remove this frame. Alright, and then these two bigger screws for the drawstring here. This is where all the magic happens. So once we loosen up those drawstrings, we can sort of pick them out. And then we can start wiggling that mesh on down. Get the frame out of the way. Get the logic board out of the way. And there you go. So we're going to grab something to set this onto that's just the same size as the rubber base, so that we can pull this mesh down without it pushing up against our table here and picking up all of our dirty table goodness here, and B, so it doesn't push into this mesh and the HomePod's resting all of its weight on the mesh and putting imperfections and marks into our mesh here. It's really easy to I don't know what the right word is for this kind of material when you basically dent it, but go ahead and rotate this around, and we need to get this cable detached from this plastic basket here before we start unscrewing and prying it off. We don't want to rip that cable. We don't want to forget it and then go and pry this basket off and forget to detach this cable here, so it'll easily tear. You'll see a little better what I'm talking about when we get this off. But let's go ahead and pop these rubber covers off for the screws on the basket here, so we can take those out. And then let's get those 9 screws around this basket off. Alright, so if we didn't already detach the cable from our basket here, we will want to go ahead and do that now. And then we can grab our big fat flathead here and wedge that in between the subwoofer and this plastic basket here and start prying this bad boy off. Yeah, and this one's given up pretty easy already. Not bad. Don't need to overwork one area, just give it a few twists and pries and then move on to the next area, and if you need to, just go around it a few times. When you get close to this cable here, do not don't stab it with your screwdriver, because these are really fragile and easy to tear and damage. So just avoid prying right near this cable. You can skip it, you can go before and after it, just don't pry right on top of it, because you will stab and damage that cable. And I am low supply on replacements for those, so if you need to pick up a replacement from me, I don't have too many left. I do have a few, but just be careful, be patient, take your time. It took me like 2 or 3 hours just to open up my first HomePod. It's taken me 6 to 8 months to get to where I am now, where it only takes about 30 to 45 minutes to fix it and have it back together again, but take your time. And once we've got that, we've got that relatively loose, we can just pry that off by hand. Make sure we don't take that ribbon cable with us. This is that part where we want to make sure this is detached, so when we pull this basket off, it doesn't tear our cable off with it. And look at that. The irreparable, not so much. Quite repairable in my opinion. Oh yeah, I really love doing the repairs live. It's when I was a kid, I loved going to the mechanic whenever my parents had like car problems, and the fact that you could just sit in the lobby and watch them work on your car, I thought that was really cool. And I always wanted to have my own sort of like repair business. And I think this is a really cool kind of like mix of the two, where people can tune in and watch if they want to see what's going on, ask some questions, you know. Alright, so we got the subwoofer out. This had no power issues. I have no reason to believe there's anything wrong with the woofer, but since we have it out, we can go ahead and look at it really quick, just check its condition. We're going to gently push it in, and that feels nice and smooth. If we turn it to the side and look through our little inspection port here, we can see our voice coil wrapped in copper. And if we take a look at one that's burned out here, you want this nice golden copper color on your voice coil. If you see this dark, charred, burned nastiness, then chances are your subwoofer is, if not already, on the way out. So this one looks good, feels good, and it smells great. It smells quite fresh. So we'll set that to the side, and we will continue on with disassembly here. Let's go on ahead and push that logic cable through so we can unscrew these rings and pull those out. Alright, we can pull this ring out, set it to the side, unscrew this ring, set that to the side, and then we can start working on the inner machinations of this here HomePod. We'll start by unscrewing the power supply with the 4 screws holding it in. If we're having a really bad day, then the thread locker they use on these screws is just absolutely obnoxious sometimes, and you'll end up actually just snapping one of these screw heads straight clean off. That's always a fun time to fix up. Haven't seen that actually in quite some time, so it was a weird string of coincidences. It was like 2 or 3 HomePods within the same week that I got that had the same issue with that, where the screws were thread locked in so well that they just broke right off, and I had to replace the threads in the amplifier board. Alright, so we got that power supply out. Now, given that we saw power being drawn from the wall using our watt meter here, I have no reason to believe that the fuse in this power supply is bad. That's also a fairly common way for these HomePods to fail and no longer power on, of course, and that's the primary protection right there for power surges, is this fuse. It's a common misconception I see floating around where people associate power surges with their HomePod no longer powering on because of a shorted diode, and that's not the case. The diode is much further down the power line for it to be, it's too far down the line for it to be affected by a power surge coming from your wall outlet. The fuse in your power supply is going to be the first thing to blow and stop that power surge. So the reason why I'm 99% positive it's the diode here and nothing to do with the power supply. Again, we saw power draw, and that means that this fuse is likely good. So we'll set the power supply to the side. And let's go on ahead and take this amplifier board out, and we'll take a closer look at how we can diagnose that. So of course, let's get that logic cable there detached. And then we've got 14 more screws to go, and this guy will come right out. The reason why the diodes on these amplifier boards like to short out and cause these no power issues is honestly, to be frank, it's unknown. Nobody, at least outside of Apple at the moment, knows for sure why these diodes fail. I have my suspicions based on how many I've had come in for no power issues or otherwise. There's a date code on the diode, and if it says 1746K or 1748K, every single time I see that date code, the diode's fried. And every time I've taken a HomePod apart for other issues unrelated to no power, they've had completely different date codes on their diodes, be it older or newer. So I'm suspect of the diodes produced between 1746 and 1748K, but at the same time, I feel like I don't really have enough accurate information to really make that call, because I could be dealing with a lot of bias here where I'm only seeing the ones that fail, and I have no idea how many of these diodes with whatever date code on them. I don't have a clue how many are actually out there. All I get to see are the ones that fail. And the only thing I've noticed so far is that date code seems to be fairly common. So let's get that amplifier out, and we'll take a closer look at what I'm talking about here. All right. So here's our amplifier, and our suspect diode is located right here. It is a 60 volt 5 amp Schottky barrier diode, and it loves to short out and go through these. The short will go through these tall capacitors here, and that's what causes the warmth on the side if you leave it plugged in for an extended period of time. But I'll bet you lunch that this diode has a date code of either 1746 or 1748K. And if that's the case, we will go ahead and test it really quick and see if it's shorted. And sure enough, we've got 1746K. So we'll go ahead and get our multimeter out here really quick. Bring that up on the camera. We're going to switch our meter to continuity test mode, where it gives you that feedback if it detects continuity, aka a short. And it doesn't matter what polarity you've got your probes here, just stick one probe on the big pin on the bottom of your diode and go ahead and probe each of the two little pins on the top. And if this diode is still good, we shouldn't hear any beeping. If this diode has failed, then we're going to hear the meter tell us that there's a short or continuity through and through. So yep, and yeah, both ways through, this diode is shorted. So we know for pretty much certain here that that is our problem. So we're going to now break out the heat gun, and we're going to tear that sucker off and replace it with a new one. to do that, we're going to grab some flux and just put a little bit of that on there, or a lot. And then we'll get our hot air. We've got it cranked up pretty much all the way here. And if we want to make this easier for ourselves, we can actually flip this board around and hit the back side of the board for about 10 or 15 seconds with this heat. And then once we've got the back side of that area preheated, we can set this back down and go to town on the front side of that diode. That should significantly help with the amount of time that we have to keep this under heat. And we're just going to keep swirling that around and poking that diode until, and we're gently poking it. We're not, trying to thrash it around, but we're just gently poking it until we start to see it give up and wiggle. And it's really taking it today, huh? There we go. So we see that solder starting to ooze up and wiggle. So we're going to push this diode straight down and off. That is how you avoid knocking off any of these tiny little components up here or this capacitor right here. You want to push that diode straight down and off the board. You can try to pick it straight up if you want, but sometimes when you're trying to pick those up, your tweezers will kind of like snap off the component and send things flying everywhere, and now you've got more work for yourself. Good times. Don't ask me how I figured that out. So anyways, we're going to get out some fresh parts. We've got a brand new 60 volt 5 amp Schottky barrier diode. The part number for this is PDS560-13 or -13. You can get those from DigiKey or Mouser, or you can pretty much just search Google for that part number and find it wherever you may be able to find it. They should only cost no more than about $1 a piece, but of course you can get some good discounts if you buy a bunch of them. And we're going to put some flux onto our new diodes so we can add some solder to the pads on that. Give us a nice solid quality connection when we put it onto our amp board here. So we're just going to put some fresh solder onto our iron here and then get that onto our diode. Too easy. And then let's get some flux on our board here. And then we can toss this around a few times until it sits the way that we want, and pop that onto our board. Alright, it doesn't need to be perfectly aligned. Just try to get it kind of aligned and to the point where every pin is on its respective pad but not touching anything else. And then we can take the heat and let the flow of solder do the hard work for us, pulling that diode where it's supposed to go. And it actually kind of moved a little bit on us, so we're going to bump that back up. And we're going to keep heating this up until we see the solder start to melt and that diode sort of just suck itself into place. Pretty much just like that. And then we're going to push and hold down on that. Give it a few more seconds of heat, and then continue holding down as we pull that heat away until the solder cools down and hardens. You'll see the texture just like that. You see the texture change from super shiny to this dull here. That's when you know you can let go. So, that is about all that's needed to repair this no power issue. instead of just throwing this into the pod and hoping that everything works, we're going to slap this together on the test bench here and do some sanity checks here. So we'll get ourselves a power supply and connect that. And then we're going to put a couple screws into that so it doesn't wiggle around and cause any shorts. Very good. Then we're going to grab ourselves a ribbon cable for the logic board. Get that connected. And then we'll grab ourselves a logic board. This one I've already gotten set up and paired to my home, and it's also got a display connected to it, so we'll be able to interact with this. And then we will connect a subwoofer so we can check for sound. And then we are going to grab a power cable, wherever that may be. Here we go. We're going to connect the leads from our multimeter up to the subwoofer here so that we can check for any DC offset that the amplifier may have. It's always a good thing to check for any DC bias or DC offset on the subwoofer if you've got this stuff apart. It's the root source of all evil, death farts, popping and crackling, etc., etc. I've got plenty of information on my website if you want to read more about that DC offset. But without further delay, let's connect this to power and check our work here. Drum roll, please. Right on. Got that no power fixed. So we're going to let this boot up, and then we're going to check that it has sound and bass, of course, and we're going to see how much DC offset, if any, that this amplifier has. And if it's above a certain threshold or it's steadily increasing, then we'll go ahead and do the DC offset repair while we've got it apart here. So we're going to wake up the amplifier now that it's booted up. When your HomePod first boots up, the amplifier isn't actually turned on. You actually have to trigger it somehow via, Siri or connecting to it via AirPlay. But we can just tap and hold on this to turn that amplifier on. And we heard the Siri prompt from our subwoofer, so our bass is good. We've got sound. And our DC offset measurement here, this is in millivolts. And we've got a spectacular 1 to 2-ish millivolts of DC offset here. So that's really good for this. It's pretty much unavoidable. Every amplifier is going to have some amount of DC offset bias. Ideally, you want that below 50 millivolts, 50 millivolts of DC on your subwoofer. When you start having more than that, you can start hearing more audible popping sounds as the amp turns on or off, and it can cause damage to the components on the amplifier and your subwoofer speaker, as well as the popping and farting and crackling in the bass, So, of course, this board, we've been talking here for a minute or so, and the offset has been holding steady between 1 and 2 millivolts. So this board is A-OK and ready for us to put into their HomePod shell. So let's disconnect that from power, take away our multimeter there, and get all these spare parts torn off so we can put this amplifier into their HomePod. Let's get that power supply off here. Welcome everybody that's been recently joined the stream. Hope you're all having a good Wednesday here so far. I'm having an alright one myself. Had quite a bit of work today at the office, and then came home to 3 HomePods that needed to get fixed up, so not a bad day for us. Let's get that amplifier carefully dropped in. We want to make sure that we set that in lined up, and we don't want to just kind of jam this in there and then spin it around and line it up that way. We want to set it in lined up, because if you look underneath, that's how the tweeter speakers connect to the amplifier, and these are obviously conductive terminal posts here, and if you're sitting there spinning the amp board around, you've got plenty of opportunity here to short things out. These caps here will hold a charge for quite some time, especially if you just tested this your amplifier by powering it on. You want to be careful when you're putting this back into your HomePod to avoid any shorts and, more damage and work. And then we can go on ahead and let's see, can you show us maybe the fuse? I have to buy a fuse, but it's without the arms. Absolutely. So I can show you where the fuse is on the on the power supply here. If you go to my website, nixfix.com or homepodrepair.com, either of those will get you to the right place. Go to the common issues section, and I have a spot for no power blown power supply fuse. I have the location of the fuse in there. I've got pictures of where it's at and how you can test it with your multimeter with it still in the HomePod. And I also have the exact part number that you need to order to replace this fuse. It's not just any normal 250 volt fuse. It's a little special. Not too special. You can still get them really cheap. But that fuse is going to be right here. This thing here covered in this black heat shrink, and you're going to need to cut away this epoxy here in order to pull this old fuse off and get a new one on. But that's where your fuse is, right in there. So I don't remember the exact part number for that fuse off the top of my head, but again, I've got that on my website under the common issues section, so feel free to check that out. And I hope that helped. I hope that answered your question. So when you're looking for that part number, just go to my website and search for that part number on my website on Google, and you should be able to find the part. Most places that you can buy this part have pictures showing you what kind of legs the fuse comes with. The fuse, and also you can just cut the legs off of your old fuse and solder that onto your new fuse if you can't find a fuse with those legs. But if I recall correctly, if you search on Google for the part that I described for the fuse, then you will find the right fuse with legs already attached to it. And I suppose we can go ahead and see if I can't pull that up on my browser here for you. So here's my website. Let's go ahead and just click common issues, and we're going to scroll on past these, and here we go. No power blown power supply fuse. So here's the repair. If the fuse is blown, you should replace it with another T3.15AH250V fuse. And if we search for that on Google, and we will find a couple here that don't have any legs, but then you've got this eBay listing here, and these guys have a picture of theirs with legs. So you could get this one off eBay. $5 with $3 of shipping. It comes from Hong Kong, so maybe not. But here we go. Here's another guy here. And if you want, you can add axial lead to your search term, and that should help you find these fuses. Or you can just cut the old legs off of your fuse and just solder that on and reuse those. So, okay. As far as I know, there's no problem with cutting the legs off and reusing them. I would not suggest just using any regular like copper wiring or anything instead of those legs. I would certainly use the either buy a fuse with the legs or cut the legs off of the old fuse and use those, because those legs are going to be at least rated enough to support the point where the fuse is supposed to actually blow. So you don't want to accidentally put in something significantly weaker than it was designed for, because then you'll end up having to take it apart again when it experiences something insignificant. Most likely not. Most likely you replace the fuse, it'll work fine so long as you don't experience another power surge. You could use frickin' soldering wire itself. You could just use a length of solder wire if you really wanted to, and it would work. But there's a difference between making something work and making something work right. You have a blown fuse and a shorted diode. The strange thing is some parts around the diode also look shorted. Interesting. I'd be curious to see pictures of what you're seeing there. I've taken a HomePod apart before where the large capacitor here was completely blown. And, I have it right here actually. It was blown and it was leaking a bunch of juice, corroding the power supply board and a whole bunch of parts on the amplifier board. So if I see corrosion like this, I'm probably going to pretty much replace everything. This is like worst case scenario, and this is the only one that I've seen this happen on. Not quite sure what caused this, but surprisingly the fuse itself is still good. But if I see, if you have like a shorted diode and a blown fuse, and you see other things shorted out too, I'd be scratching my head too. So we don't want to forget that ribbon cable there. Let's get that connected to the amplifier and then properly lock that down. There we go. So that's nice and level, and this locking tab is pushed down. It's kind of deceptive. Locked looks open and unlocked looks closed. So quite the odd connector there. Let's get our power supply dropped back in here, and we want to make sure that that's lined up with the screw holes underneath before we push it down and connect that that connector underneath it. And then we can plug the AC terminal back in and screw it back into place. Alright, power supply is in. We're going to do one last sanity check. We've got the leads plugged into the power supply, and we've got our logic cable, our ribbon cable here connected to the amplifier down there. It's level and locked into place. So let's go ahead and start putting the rest of these parts in. We're going to start with our first plastic ring here. We're going to find that notch on the inside and set that straight down, lined up with our logic cable here. And then we're going to rotate that counterclockwise 90 degrees until it snaps down, and then rotate it back clockwise 90 degrees until it's lined up again with our logic cable here. And then we're going to pull this grommet off so that we can feed the cable through the next plastic ring here. And again, we're going to make sure that this is like centered with our cable here, and then we can push it straight down. And then we can push down with our finger on one of these screws, and with our other hand we can reach underneath and wiggle the plastic ring underneath, just to make sure that the holes and the screws for both of these plastic rings here are lined up nice. And then we can screw those down. Don't need to tighten these ones too much. Keep in mind they've got gaskets on them, so if you over tighten them, that is going to do some damage to that gasket and potentially cause issues with your subwoofer properly sealing. You want them firmly snug. Then we can grab our subwoofer. Ooh, we almost forgot. Do not want to forget that grommet for the logic cable here. Let's get that slid back on and push that into place. And when we get it pushed into place, we want to make sure that we can pull this logic cable out carefully until we just barely start seeing the first line on there. And then we'll make sure that that grommet didn't get pulled out while we were pulling that cable out. Make sure we've got our subwoofer grommet here, or our subwoofer gasket here, nice and centered. And then we can grab that subwoofer, reach in there and plug that back in, and then gently feed this cable through the subwoofer and set this down, making sure that we don't pinch any slack from this cable here. Alright, we can go on and screw the woofer into place now. So let me ask you this, Doctor Liverkai? Doctoro Liverkai. Okay. Well, you know who I'm talking to. Tell me this. Do the parts look shorted? Or are you saying the multimeter says that the parts are shorted and they look okay, but your multimeter is screaming to you that a whole bunch of stuff is shorted? Because it's, certain parts will have, it's normal and it's expected to have continuity through all sorts of parts on the amplifier, like the inductor coil, for example. And I apologize if I'm insulting anybody's intelligence here, but I figured I'd explain this anyways. So, like, for example, this big inductor coil here, I would expect this to have continuity through itself, and if it doesn't, then that would mean it's bad. These rarely fail, but just as an example, right, so, okay, the multimeter scream, cool. So, it's totally fine. Don't put your meter into continuity test mode and then just start probing everything around the amplifier board looking for things that are shorted. You do kind of need to know what the component is and its normal behavior in order to determine if it's supposed to have continuity or not. So again, this diode here, it's supposed to not be continuous. It's not supposed to have continuity going through it. This inductor coil is. This inductor coil is actually supposed to. So if we peek that, you can see our meter scream, but that's a good coil, and that's expected. So start doing research on different parts and what they're supposed to do. Just because your multimeter screams at you when you touch the probes on a part doesn't necessarily mean that part is bad. Another trick, another thing you got to watch out for is, let's say you're testing your diode here and you know your diode isn't supposed to have continuity. You know your diode isn't supposed to show shorted on your multimeter. Then you go and you probe it with your multimeter and it shows shorted. So you're like, okay, you should pull this part off and then test the part off of the board and see if the part itself is shorted, or if you've got a short on the, coming from somewhere else on the board that's contaminating your test for that part. So things to keep in mind, and as you work on these things and gain experience. So what about the bigger one behind the diode? So I'm assuming you're talking about the brown capacitor up here, this guy. So that's a capacitor. Let's check it really quick with it installed on the board. And my meter will briefly beep at first when I connect it, but it does not continuously beep. So this capacitor here shouldn't show a short. This big one right here above your diode, directly above the diode, it shouldn't show a short. But just because if you test it, it shows shorted, doesn't mean that the diode or that capacitor itself is shorted. Go ahead and pull that capacitor off, retest it with it off the board, and then if you don't see the component as shorted by itself, then go back to your board and test more. So there's some electronics 101 for you. I'm not the best teacher, and I will be ready to admit that I'm not. I'm far from like a pure expert on electronics repairs, but I do like to think I kind of know what I'm doing here. Just a little. I would say like a good half to 3/4 of my knowledge on electronics, audio amplifiers, and just repairs in general. Most of that I've learned in the past, within the past year. That, a little more, 8-10 months. Oh God, I'm stuttering. Okay, let's get our top basket here, and we're going to set that down. And we want to push that down and make sure that we've got no significant gap all the way around this. All right. So then we can go on in and screw this basket down as our HomePod slowly retakes its original shape. Yeah, so go ahead and pull, if your diode shows that it's shorting out, go ahead and pull the diode off of your board and test to see if the diode is still shorting all by itself, not installed on the board. If the diode is still shorting and your meter still screams at you when you test the diode off of the board, then go to your board and check if the pads from your diode show any short. I would be pretty surprised if you've got more going on, but at the same time, if your power supply fuse was also blown, then that's oh, you know what? Let me ask you this. Your power supply fuse, is supposed to scream. You're like, if you get your multimeter and you're probing your power supply fuse, you want that to scream at you. You want that to have continuity. That means that your fuse is good. If your fuse is blown, then you test it with continuity and you'll see that there is no continuity, so your meter won't scream at you. Your fuse is blown in that case. Yeah, there we go. Now I think we're getting close to the same page here. No, you're not dumb, but you are a beginner. Everybody starts somewhere. And I was, to put it in your words, I was as dumb as you were at one point. So, but once you, I honestly, if I were you, I would just start searching YouTube for just basic electronics repair videos. Go watch some earlier videos from Louis Rossmann. His more recent repairs, he doesn't really talk much about the basics anymore, because you can only talk about the basics so many times on live stream over and over again before you kind of get sick of it and don't want to keep re-explaining the same basic thing again. So go back to some of Louis Rossmann's older videos. Check out Northridge Fix. They've got some excellent videos with lots of great knowledge riddled throughout. Those guys are incredibly smart, and they pretty much know everything that they're doing and why they do it. They're the reason I'm here doing this. I probably never would have considered starting a YouTube channel for showing off repairs, let alone even offering repairs, without them. I would also suggest, while I'm throwing all the books at you, I would strongly suggest looking up like basic soldering videos. I can't remember, it might be Pace or someone else. There's this really old like 70s or 80s style instructable video on like the basics of soldering, and it's really interesting to learn how soldering actually works. It's not just, you know, hot metal holding two sparky parts together. It's creating a new alloy and a physical bond if you do it right. And learning how to do it right and learning about the magic of flux, I'm telling you, it's game changing. Up until about a year ago, I had barely used any flux. I didn't really understand how soldering really worked. I knew well enough to get a soldering iron hot and melt a couple wires together with some solder. And that's about as good as I was. To do board repairs, you got to learn what soldering actually is and what it's doing, and understand what's actually occurring in order to get a good quality, lasting repair out of it. So, on the list of suggestions, just look up on YouTube some basic soldering technique videos, and learn about what soldering actually does. Learn how useful flux can be and how much easier it can make your work. I mean, the difference between using flux and not using flux is pretty much the solder doing your job for you, or you sitting there for hours on end being all frustrated with, burning parts and such, with things just not seemingly soldering together. Flux is that magic bit. I love it. I could go on and on about flux. Alright, we're going to screw this frame in. We're going to do these 4 screws for the frame very loose. We're only screwing it in about 2 or 3 turns or 2 or 3 threads, because that will give us room to feed the mesh here into the lip on the side of this frame. And I'll show you exactly how we do that. So if we grab our 2 drawstrings here and we start pulling them straight up, and we can start pulling this mesh into that frame there. You can see it sort of like pop in there. And if we keep pulling on these strings, that should help tighten it up. And then if we want, we can grab those and pull them away from each other a little bit to tighten that up a little more. And then we're going to push down on this frame and hold it down while we screw it in. Alright, and that's how you get your mesh looking good. Looking nice and OEM again. So let's go ahead and screw these drawstrings back into place. No reason to excessively tighten these big screws. All they're doing is just holding this string in place. Once you wrap them around these posts so many times, and I mean, once you've got this whole thing screwed down, you really don't have to worry about this undoing itself. And these screws very easily strip the plastic threads underneath, so just go easy. Alright, we are nearing the completion of this first HomePod here. It's taken us quite some time, but you know, what can you do? We're hanging out, we're having a good time. Is there a way to destroy this touch panel? Yeah, I mean, you could smash it with a hammer, or I'm kidding. I know what you mean. Yeah, you can hurt this panel for sure. When you're prying this panel off, make sure that you're prying this panel off with both layers. Don't separate this plastic layer from the PCB underneath. Pull this up as a single unit. And when you're prying this up, try to use a plastic tool, and don't go very deep. Only go like a centimeter at most in, because you've got these components here that you can slice off, and you've also got the ambient light sensor here that you can slice off. So, yeah, yep, yours was in 2 parts, so chances are this got pried up separately, and that will, it's not certain failure if you accidentally pry these 2 layers apart. You can just stick them back together. Heck, the touch works just fine without this plastic layer on it, as a matter of fact. What you risk damaging if you pry these up in 2 separate layers is this ambient light sensor right here. You'll end up breaking this off the board. There isn't really anything else here that you can hurt, but if you break off your ambient light sensor, then you simply just don't have automatic brightness anymore, and whenever the display is active, it just operates at full brightness, which really isn't that big of a deal. Touch should still work. But let me grab another touch here, and this one was unfortunately subject to what you're talking about. It was separated into 2 pieces, and the previous owner used a metal tool when they were doing it, and that resulted, they didn't knock the ambient light sensor off, surprisingly enough. It's still there, but they broke this display because they marred and scratched up the PCB itself with their metal tool. You can't see it too well. Maybe you can right in there. But that is definitely one way you can destroy this display and touch sensitivity here, is by getting in between these 2 layers and or using a metal tool and scratching this up too much. So, right. without further delay, let's put these screws into the display. Get the top surface stuck back on there, and then we'll do a quick check on this guy. And then we can move on to our second HomePod that has no base. Ooh, interesting. No base. Base. Yeah, honestly, just stick it back together. You can turn this. You can test it. You don't need to screw this display back in. Just plug it back in and set it down. Leave your touch cover here off, and power it on and see if your display is working and the touch works before you go and screw it down and stick the top on and find out that it doesn't work then, and you got to tear it apart again. All right, let's get our heat gun here, and we're going to carefully, very carefully hit this with a little bit of heat. We want to focus on the adhesive, and we want to avoid the center and the edges around the mesh. We want to get just on that adhesive. No more than about 10 seconds if we've got our hot air turned up to the max temp, and then move on to our touch panel here, or our touch cover. And a good rule of thumb that I like here is if it's too hot for you to hold, then it's probably too hot for your plastic part. So only a few seconds for each of these. Switch between them, go back and forth until you've got those warmed up. And then we can start by lining up the positive, and the positive here, we'll just set the edge of the touch cover here into this lip in between the mesh and the frame, so we can sort of like hinge it like this. We're going to line up the positive there, and then as we angle this down, we're looking from the other side to line up the negative. And then before we push this down, we're going to look at it straight down from the top, and we're going to push down on the edges here, and we can sort of feel where center is. You can only really get this from experience, but you can sort of feel and readjust this if you can't tell from looking at it straight down where exactly center is. Once we've got that where we feel it's nice and center, we can push that all the way down. And then we can now finally test it. So let's get our power cable here and just pop that in. Yeah, plastic card's a good idea for prying these off, because obviously the metal is much harsher, but the plastic credit card, I've seen a few people use those before. So not a bad idea. But let's go on ahead and plug this into power. And drum roll, please. We got power. Yeah, baby. So we're going to let that boot up. And then we're going to check that it's got sound still, both treble and bass. And then we want to check and see that our volume buttons light up nice and even, because if we don't have this like centered or oriented the right way, then one of the volume buttons may look a little uneven or dim. So let's prompt up Siri and hear for sound.
I'm having trouble connecting to the internet.
Yep, so the bass and treble are clearly working. And our volume buttons look nice and perfectly even. So this one is all ready to go. Short of factory resetting this and doing a thorough sound test, we'll go ahead and disconnect this from power, set it off to the side, and we'll get our second pod here and switch up our repair text so people know what's going on. All right. So this is the one that Kathy sent in a few weeks ago. I can't honestly remember what the original issue was. It might have been no bass or no power. But in any case, when they got it, they had no bass again. So I'm kind of puzzled as to what's going on here. I check all of them for, as you see on stream, and we could probably go back and check the repair stream from Kathy's a few weeks ago, just to double check, but I check all of these after I fix them up for sound, both bass and treble, and the lighting up of the volume buttons. So for it to be tested by me and then sent and then have no bass after they get it, that is interesting. But we will get to the bottom of it, and I will happily admit mistakes if I make any, because, well, if I won't learn from it, I hope somebody will. So let's connect this to power. Hide that other camera for now. Alright, so it's booting up. And the fact that it's already showing the animation without me having to touch it tells me that this was factory reset, so it's probably going to start up and play the first time setup chime here. And yes, indeed, that is a significant lack of bass. Quite interesting. Okay. Well, let's go ahead and tear this apart. Good thing for us is, well, we have already taken this one apart once before, so it should be pretty easy for us to get back into this again. Let's see. Do you know how many HomePods you've repaired already? I can't say for certain. However, I can say that I've definitely repaired more than 100, 125 at this point. I know a few weeks ago somebody asked, and I estimated about 100, but you know, obviously in the past few weeks we've gotten dozens more, so I know I should be keeping better track of some of these things, but you know, I focus on what I'm good at, so I will improve where I can. I've got some, I have access to some valuable data here, having gone through so many of them for repair. I just need to come up with a better way of logging all of that data and making use of it. Alright, let's get that side angle back up here. There we go. That lovely, lovely angle. I do like it. Let's get that display off. Should come out pretty easy. And then our frame. Well, what could be the problem here? Did we forget to plug the subwoofer back in? Did the bass blow up right as soon as they got it? We will find out. I'll also have to go back and rewatch my repair for this one so we can find out if I made any mistakes along the way, or perhaps misheard the sound test, because it's quite odd that I would have not noticed that this has no bass. And of course, I'm not charging them for having to send this back and get looked at again. This is 100% all me. I got their shipping covered, and of course they won't be paying anything for having to send it in again. And I also give a 6-month warranty to all of my repairs. So if anything that I do fails within 6 months, I will cover the shipping for you to send it back in to me, and I will get it fixed back up again for you, free of charge. That, of course, that doesn't cover, and I cannot cover issues with software, or if your logic board decides to break itself a month later. There's not a whole lot I can do about that. I don't have logic boards available to just swap yours out, and yeah, it's unfortunate that I can't really do much about those, but it hasn't happened, so hopefully we won't ever have to deal with that. What could be going on? What is inside? What is happening? Yeah, we'll cruise. We'll probably cruise right through this one because it's already been taken apart, and hopefully it's just a simple, very simple issue here. I don't think the subwoofer's voice coil is burned because I would see a heat spot on this dust cap right here. If we look at any of these that have been blown, you can sort of see the middle of the dust cap has a sort of duller texture than the rest of it on the outside here. Those are all signs that clearly the voice coil was overheated and blew out. But this one looks fine. So I don't have any reason to believe that the subwoofer is bad, but who knows? Maybe the wiring that goes to the voice coil just broke off and it didn't overheat. Let's find out. So the subwoofer is plugged in. Don't see any issues here. Let's go ahead and test this subwoofer really quick. So we'll scooch this over to the side a little bit. And we will plug this guy into this amplifier. Let's get our good logic board on here. And I think that is all ready to power on. So, what do we got here? All right, do we got bass? Yes, we do. Oh, do we?
You'll need to update your Apple Music subscription to allow me to do that for you.
Interesting. Oh no, I'm touching the wrong woofer, lol. That's hilarious. Okay, yeah, so this bass speaker is working. I feel it moving around, and let's just play some music through it really quick, because why not? Just a quick bump. I believe I named this one Come on. Tortured soul? Where are you? Where are you at? Yeah, there we go. Let's turn that down. We don't need it blasting. We just need to see that bass speaker working consistently. Oops. Bass test. Ultra deep bass test. Yeah, that's my jam. After these quick ads.
Washington State residents, if you have a utility meter like this on the side of your house, you can get paid to go solar for no money out of pocket.
Oh goodness, yeah, that works for sure. Wow. Okay. Alright, so we'll unplug that from power so we don't risk damaging anything here, shorting anything out. Let's get that woofer off here and set it to the side. And let's get this amplifier out, because subwoofer's fine, so it must be a problem with our amplifier. It's not a problem with the logic board, because if it was a problem with the logic board, we wouldn't be hearing any sound. The logic board is sending a digital audio signal to the amplifier, where it then splits to the subwoofer and the tweeters. So, I'm not expecting to see anything obviously wrong with the amplifier. And honestly, we're probably going to end up pulling an amplifier board from a different HomePod and replacing it entirely. But let's see here. Cause I'm not sure I really want to go through replacing the amplifier chip and the capacitors and just going down a whole rabbit hole of trying to figure out why this amplifier doesn't have bass, at least on stream, at least here today. I will set this amplifier board to the side if there's nothing obviously wrong with it, and I will get to it. I will get to the bottom of it. Let's get that side angle out of the way here. Alright, the grand reveal. What do we got here? So we've got a new diode on there, so I did some no power repairs on this, or I just preemptively replaced it. Now let's flip this around. I did not do any DC offset repairs here, so I must have tested this board. This board must have tested good at some point, and then for whatever reason it's decided to no longer produce any bass. Yeah, nothing sticks out. Well, let's see here. Let's go ahead and grab another HomePod off the parts shelf. And here we go. So we could go about this one of two ways. This one's got blinking volume buttons, right? So we could simply swap their good logic board into this and then just give them this. Or we could tear this whole thing down just for the amplifier and put that into theirs. Now, yeah, and their mesh is in really good shape here. So that would be a fair trade here. And that would give me more time to figure out what exactly is wrong with their amplifier board. So I think we're going to go ahead and do that. We're just going to swap their logic board into this bricked HomePod, and that should get them very well taken care of for the foreseeable future. And it'll be significantly easier for us today here. So let's just get that top cover pried off real fast. Yeah, some people wash the mesh. You can just use hot water and dish soap or like laundry detergent to clean your mesh. If you don't want to take it off, you want to leave it on the HomePod, then you can just get a clean rag or Q-tips and rubbing alcohol and use that to clean certain spots off if you've got any stains. Let's get this display off. And these should be the last screws we'll need to take off. And we'll get that bricked logic board out of the way here. And we will put in their good logic board. And put that right back together. Get that frame back in. Get the display back on. If it's just dust in your mesh, you can use tweezers to pick it out, or just get some dust in a can or an air duster and blow it off. The HomePod Mini is sad. That HomePod Mini will boot loop until the day it dies. Or decides to no longer boot loop. Whichever comes first. This HomePod this HomePod that was originally bricked here was actually the HomePod that was in my earlier video upload, not a live stream, but my actual video upload where I bought 2 broken HomePods from OWC. I think for like $100 each, and both of them ended up being bricked, but I held on to them in case I could. Well, obviously for parts, but I never got around to taking them apart yet. And I'm glad that I've found a good use of this one. Okay, so this was Kathy's old HomePod shell. This was her old amplifier. What we've gone ahead and done is taken her good logic board and replaced the bricked one in this HomePod. It's in pretty much exactly the same shape as hers, maybe a little nicer. As an easy workaround here, I'm not sure why her amplifier doesn't produce any bass, but we will get to the bottom of that at some time in the near future. For now, our priority is getting Kathy a working HomePod again. So let's get power and check that this all works. Alright, good. So it's powering on. Alright. Camera died because the HomePod setup prompt came up on my phone, and my phone is my camera, of course. There we go. So I heard some pretty healthy bass in there. So I feel like this one is ready to be sent back to Kathy. Go ahead and unplug that from power. Set it on to the side, and we will break out our third and final HomePod for repair today. We'll go ahead and update that text status. Alright, so Ja here has got no power. Let's see if that's the case. Yep, nothing on the pod here, and 4-ish watts from the wall, so pretty typical shorted diode signs here. Let's get that power cable yanked off and dig in. Alright, so we got our pry tool, got to clean that gunk off so we don't get that all over there. Very minty mesh here. Alright, let's begin. Looks like the top here's got a little tiny crack on the side right next to an impact mark on the factory screen protector here. So we'll want to be careful working around that so that we don't make it bigger than it already is. All right. Set that to the side. Let's break out that side angle again. Oh, and of course the HomePod prompt killed my camera. Give me a sec. There we go. All right. We got a bunch of screws here from the other ones. Let's get all that set to the side. There we go. Let's get this display pried out. Both layers, of course. There we go, easy peasy. right, let's get this frame out. Frame is out, logic board out. Where's our base? Here we go. Base. Come on. There we go. Get that logic cable unstuck from the basket here. Too easy. Let's expose the screws for the basket. Let's get that basket unscrewed. All right, time for the pry of shame. Oh, well, that's coming up real easy. All right, I'll take it. Oh yeah, real easy. Nope, I knew that felt weird. We've got one more screw. I don't know how I missed them. There we go. Now we can pry that. Skip over that logic cable. And this thing feels ready to pry. Oh yeah, that came off real easy. Cool. Let's get that set to the side and get this subwoofer out now. Alright, woofer is out. Might as well inspect it. Feels good, looks good, and smells great. Set that to the side. Get this logic cable pushed through so it doesn't get torn apart when we pull this ring out. Then we can unscrew said ring. That should just come on out. Get this taken off. And then we can get to that power supply. So we'll take those screws out. There we go. Would you say the HomePod is a good quality speaker? I mean, everything is sealed so nice. Yes, this is, I think still, you know, despite its faults, this is an incredibly well-designed and very well-performing speaker for what it is. I mean, I challenge you to find a speaker that costs less than $300, that has a built-in subwoofer and 7 omnidirectional BMR tweeter speakers, and basically an iPhone 6s or iPhone 7 crammed into it to run the whole thing. You'll be very hard-pressed to find an omnidirectional AirPlay speaker that performs as well as this for this cost. And that's generally the case for a lot of Apple products, right? Like, I don't know. Maybe it's not. And it probably isn't for a lot of their things, but I feel like the HomePod was one of those Apple products that just, it seemed expensive, but really for what it is, you'd be hard pressed to find something better. And even to this day, I'm not aware of a speaker that has comparable specifications to the HomePod. Sure, you've got the Sonos and other speakers out there, but they're either they're either not omnidirectional, or they're smaller, and they just don't produce as much of a sound as these guys do. So, I absolutely think that these were some of the best speakers ever made, despite their problems. Like, I love them, and that's why I still fix them. Aside from all the you know, green reasons and e-waste reasons and saving things from the dump, I could have done that for any number of things, but these I saw nobody really taking care of them. Nobody was really out there offering repairs and documenting the problems and trying to find you know, solutions for them. So I figured, heck, seems like an opportunity. With one of my favorite speakers too. I've got a bunch of these around the house, and I use the crap out of them. All right, so we got the amplifier out. Let's switch over to our up close camera. And there's our likely culprit, that pesky diode. What you want to bet what date code it's got on there? Wow. 1748K. So, I'm not even going to bother testing that diode. I've done this so many times at this point that I pretty much just know. I know based on what I see what needs to be done. at least for this specific problem. So we're just going to yank this off and replace it. We know this is our problem. So once we get that diode replaced, we can power the amplifier on and do our normal sanity checks to make sure that it of course powers on, but that it's also got no DC offset to worry about as well. This sucker's taking the heat. Give up. Give it up. Yeah. Let's grab a fresh diode. Get that diode prepped and ready to go. Get that old one out of the way here so we don't get them mixed up. And of course we'll get some fresh solder onto that guy before we pop it onto our board. Proceed with placement. There we go. Let's get a little more flux on there. Can never have too much. Grab our heat and put that into place. Keep holding, keep holding, keep holding, keep holding. And boom. Baba booey. We don't need to worry about getting all the flux off because it's not. It's safe flux for electronics. We can leave it on here without worrying about it corroding and causing shorts. But we will get the excess off. Okay. Let's give this a test on the bench here and see if there's anything else that we need to get fixed up on here. We'll just grab a random power supply. Oh, definitely not that one. We do not want to use that one. Not if we don't want more problems. We're going to take our time putting this back together so it gives the board a chance to cool down. Still pretty hot. Let's get a logic cable wherever we may have placed that. Where did it go? Ah, here we go. Yeah, once you do this like 100 times, you get pretty fast at it. You don't want to rush, because when you rush, that's when you make mistakes. But you do get proficient at it. Alright, let's get a multimeter connected to that subwoofer so we can check for any DC offset. We'll pull that up on the screen here too. Set that to DC millivolts. Let's just check if that's still hot. Nope, I can touch it. All right. What do we got? We got power. Of course we got power. We know what we're doing here. A little bit. Alright, it's booted up. The amp is not on yet, so we'll want to wake that up. And oh boy, look at that offset. So we started at 37. We're already at 44, 45, 47 millivolts. Let's sit here for a second and see how big that gets. We're already past 50, so we've already seen two different criteria that I hold these to before I consider repairing the DC offset. We've got more than 50 millivolts of DC offset, and that number is gradually increasing. It's going up. So if it started at like 50 millivolts and shrunk down to 0 and then stayed around 0, that's fine, because that probably means that the capacitors that filter this DC offset, they were probably just a little warm. They lose their capacitance the warmer they get, which explains why, as the HomePod runs and they warm up, you might hear more popping than otherwise. So we've been talking here for a minute, and it's now already, so it started at like 30, 35, and we're already at 80 almost here. So we should tackle that really fast. So we're going to take all these parts back off. These are all symptoms, or precursors, I should say, to the filtering capacitors on the amplifier starting to go bad and allow too much DC to be sent from the DAC to the amplifier. And then from there, the amplifier is just going to amplify that DC bias and pump it into the subwoofer. So that can cause damage to the amplifier chip. It can cause damage to the subwoofer, of course. So we'll want to nip that in the bud. Just because they sent it in for no power doesn't mean we can't check and fix the other problems here. So let's switch back over to our up close camera. Those big 4 brown capacitors right there are the ones that we'll need to replace right here. And the goal here is for us to replace these 4 capacitors and get that DC bias reading on our multimeter stable and under 50 millivolts. So the reason why that occurs is one of these 4 caps here, all 4 of these are part of the filtering circuit for removing this DC bias. and it only takes one of these four to start going bad to throw the whole thing out of balance. So we'll go ahead and pull all four of those off and replace them, and then reassemble this on the test bench and check this out. See if we got any DC bias left over. So we'll go ahead and put some flux on there to help just a little. And they should be about ready to start pulling off. They're a lot smaller and they have a lot less soldered on surface area than those diodes, so they're a lot quicker and easier to get off and put on than that diode. Granted, there's four of them, but this isn't too bad. It is not for the faint of heart, because you've got all these other little components all around them. So you need quite a steady set of hands to do this part here. All right. Got all four of those off. Let's put some fresh flux onto these pads on the board and apply some fresh solder to said pads on said board. Yeah, if you've got your HomePod apart for whatever reason, you may as well test it for DC bias on the woofer. You don't want to fry your subwoofer speaker a couple months after you just fixed it for no power, you know? Alright, so we got those pads touched up. Didn't create any unwanted shorts on there. So let's grab a fresh set of new capacitors here. I've got the part number for these ones also on my website under the common issues section, if you were curious. And we will start with replacing these. Alright, so we'll put some flux onto the first set of pads here. Pick up our first capacitor, grab our heat gun, and start working. I want to make sure we grab the middle of this capacitor so that we've got room to push it down. We don't want the tweezers being on the bottom of this capacitor here, because then we can't push it onto the board. The tweezers will stop us from pushing the capacitor onto the board. So we want to kind of grab that component from in the middle, about halfway. Get those pads melted, drop it into place and hold it for another second. Very good. Actually going to push that back a little bit. There we go. Let's get some flux onto the second set of pads and grab our second capacitor. Very good. Third set of pads. Fluxed. Grab our cap. Very good. Flux up the last set of pads. Grab our last capacitor. Halfway. Beautiful. Look at that. Frickin' work of art. Excellent joints. It doesn't look like you've got two separate blobs holding the component onto there. It's one uniform blob. Let's clean up some of that excess flux here and give it one final test. Okay. We want to give this plenty of time to cool down because we don't want the natural loss in capacitance in the capacitors being affected by that heat. Like I was saying earlier, heat affects the capacitance of these guys. So if we just jump right into testing it right after replacing them and they're still really hot, we're going to see a fairly large DC offset still. So we want to make sure these are nice and at least cooled down so that they're not warm to the touch even, because we want the natural operation of the board to be what warms them up to the maximum temperature that they would normally get to, so we can get an accurate measurement of said DC offset here. So that's cool. That's not cool to the touch, but it's not noticeably warmer than the rest of the board here. So we're pretty much ready to give this a test. There we go. Grab a logic cable. Grab a logic board. Plug in a subwoofer. We've got that subwoofer connected to our multimeter over here in DC millivolts mode. We'll get those power leads connected. And let's see what we've got. Alright, so good sign, it still powers on. Always nice to see that we didn't take any steps backwards. We'll wait for that to boot up and then we can wake up the amplifier and check our DC bias here. Alright, so I didn't hear any popping. And we've still got bass. Our DC offset here is still a little high, I think, because those caps are still a little warm. Watch this when I cool down the board with just my breath here. So like I was saying earlier, the board's still a little warm, so we're going to see a slightly higher number here. But two facts: it's well below 50 millivolts, and it's staying pretty steady. Like it hasn't doubled in the time that we've been sitting here talking about it. So I reasonably believe here that we've got the DC offset issue corrected. There really isn't anywhere else it could be coming from. It's just those 4 capacitors, because it's inevitable to have DC bias in an audio amplifier. It's those capacitors' job to remove that DC bias. So you can't really correct the source of the DC offset per se. You correct and repair the circuit that's supposed to remove that. So, and you could see as we were talking, that number continued to kind of fall a little bit. So the board is still cooling down a little bit to its normal operating temperature. So all very good signs that this board is ready for some more work as a happy HomePod with many years free of gassy farts and no power issues. I probably do not do a very good job of explaining exactly what DC offset or DC bias is in audio amplifiers, and what the implications for that offset bias are. So if any of that doesn't make sense, it's not some mumbo jumbo that I just came up with. You can go ahead and search on Google for just like DC offset in audio amplifiers, and do some looking around to if you're interested in learning more about DC bias. But let's see. We'll grab their HomePod shell. Here we go. Go ahead and turn that multimeter off. And that's how I figured out, that's how I discovered how to repair the death farts and the crackling bass and the popping and the no bass entirely. Was I didn't know what DC offset was. I just saw someone on YouTube talking about DC offset being the problem in these HomePods, but there was nobody or no ways to repair it at the time. So I did some Googling on DC offset and learned myself up. And one of the things that I noticed while I was researching DC offset and potential sources for it was the fact that temperature affects the amount of DC offset. And at the time, people thought that the source of the DC offset was coming from the amplifier chip, when in reality, after I did some digging and testing, I used a heat gun to find which area of the board could I heat up that would make that DC offset measurement fluctuate the most. And that's when I found that area where those 4 large capacitors are. And after I found a HomePod board that had like 2 to 3 volts, not millivolts, but 2 to 3 volts, full DC volts of DC bias, I just said to heck it, and I tried replacing those capacitors, and there was no more DC offset, no more death farts, no more loud popping, and it worked. And I was quite surprised. So you can go from not knowing something to figuring out a new discovery and a new way to repair something in the same day. That's gonna be my that's gonna be my claim of fame until I die, or I guess do something better with my life, is I discovered how to repair death farts in the original Apple HomePod. When nobody else could figure it out, I did. And I'll brag about that till the day I die. It will be on my tombstone. This is the guy that fixed those HomePods. Let's get that logic cable reconnected. We don't want to forget that. That would suck. Alright, and then we need a power supply wherever one may have gone. Here we go. Is this their power supply? Nope, here it is. This is their power supply. No, I'm Dirty Dan. All right. Let's get that side angle back up here. Aw, yeah. Start putting our gaskets into place here. And then, if I remember correctly, this had some extra shit here, and that will mess it up. So we'll just there we go. Very nice. It's almost 4 a.m. Goodness, yeah, I get some sleep. Thank you for joining, and thank you for asking your questions. It's always a good time. Right. And this gasket for the logic cable. Subwoofer. Where'd their gasket for the subwoofer go? Interesting. Here we go. Let's pop that subwoofer in. Almost got this woofer all the way in here. Alright. Let's get this top basket put on. Last screw for the basket. Alright. Let's pull that mesh up and get our covers put back on for those screws. Whoa, that one went flying. Put their logic board in. And then the frame. Get those drawstrings put back on. There we go. Let's get the frame loosely screwed in so we can get that mesh buttoned all up. All buttoned up, I should say. Not buttoned all. Buttoned all up? All buttoned up? I guess both are technically correct. All right. Get the display. Six concurrent viewers and 9 likes. Nice. Nice. We are almost done. Let's clean up that volume button. It's got some adhesive on it. And that ambient window there for the light sensor. There we go. And then we'll gently, carefully, very carefully, very, very carefully heat this adhesive up. Oh, so carefully. Like, goodness, be careful. All right. Let's give her a test. Drum roll, please. Power. Let's of course let it boot up and check for sound and lighting up volume lights that are nice and even.
Trouble connecting to the internet. For more info, check the Home app.
No bass. You're kidding. It had bass. The bass was working. And now it's not. What the heck is going on? Huh. Alright, let's tear it back apart. Ready for a speed run? I don't think you're ready for a speed run. I'm not ready to replace all these freaking amplifier boards that just suddenly stop working. What the hell? I'm upset. Rah! 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 Alright, you joker. What kind of games are you freaking playing on me? The bass was working. We heard the boom when we tested it after we fixed the DC bias. So why would it stop working between having it out of the HomePod and then putting it into the HomePod? What has changed? Oh. I might know what happened. Interesting. I just noticed. Huh. So I don't know if you remember, but when we were putting this one back together, when I was putting the subwoofer back in, I couldn't find the gasket for the subwoofer. This guy, right? That sits under the subwoofer. And I thought that was strange because it wasn't on the... I normally leave it... If it doesn't stick to the subwoofer, I just leave it on this when I take this off. So what I'm getting at is I think I accidentally put Kathy's subwoofer into this HomePod and mixed it up with this one. This must be their woofer because it still has the gasket on it. And if that's the case, then Kathy's no bass issue must also be the subwoofer. So. This subwoofer is probably donezo. That's interesting. Did I completely did I just go complete smooth brain when I was replacing, or when I was looking at Kathy's HomePod? Because I think I remember testing her bass speaker, but I don't know if I actually tested her amplifier. I just assumed it was bad. So what if it's the subwoofer speaker and we accidentally put Kathy's bad subwoofer speaker in here too? The plot thickens. And you guys get another 30 to 45 minutes of content. Hooray! Watching me make stupid mistakes. But that would explain why I was so confused as to where the gasket for this subwoofer went. Because I grabbed the wrong subwoofer. I grabbed Kathy's old subwoofer. So let's test that theory. Huh. Yeah, because I don't see anything wrong with this. This subwoofer. But let's grab this one and put that in. And it does not want to sit. What are you all bent up about? Why don't you want to go in there? Oh, because I'm being maximum dumb here. Take this one off. We've already got one on the woofer here. Yep, on today's episode of How Many Mistakes Can We Make in One Stream? There we go. Alright, and then before we start putting all the screws back in, let's just get a logic board. Nah. I am reasonably confident that problem was the subwoofer speaker. Yeah, you're paying attention. It was the extra subwoofer gasket. I should probably mark that subwoofer as bad before I accidentally put it into another HomePod and wonder why the bass is not working anymore. Good grief. Let's go ahead and mark that before we forget it. We're just going to put a big fat question mark on there. And we'll test that after we wrap up all of these HomePods here. Alright, so we got all those in. Let's get our basket back on. Let's see, do we think we'll get lucky? Were we correct? Did we just simply mix up subwoofers here? I sure hope so, because I really couldn't fathom what could have possibly happened to that amplifier board between us fixing it, verifying it, and then suddenly not having any bass a minute later. And that would explain why Kathy's HomePod. Oh, that would make sense. Yes. Yes. Oh, it's all clicking. My brain. Understanding. Feels good. I was really scratching my head because I was pretty sure Kathy's HomePod was working. and then for her amplifier board to suddenly stop working. Well, what makes more sense is me testing the amplifier after repairing it and then accidentally putting in a dead woofer. That makes a lot more sense than amp board works now, amp board doesn't work a minute later. And then before we screw all this together, let's just go ahead and boot this up and give it a check here.
I'm having trouble connecting to the internet. For more info, check
Huh.
the Home app.
No, so it's not the subwoofer. It's the amplifier. But it was working. Huh. Well, let's do this. Let's go ahead and grab the other bricked HomePod here. And we're going to do the exact same thing that we did with Kathy's here. We're going to put their good logic board into this bricked HomePod. And then we will do a deeper dive on what the heck is going on with these amplifier boards, because we had bass, but we had DC offset. So we fixed the DC offset, we still have bass, and then we put it into the HomePod and suddenly no more bass. It makes zero sense to me. What a confusing set of repairs today, goodness. Bricked board out. Good board in. Watch this one have no bass. I'll quit. I swear. No, I couldn't quit this. It's too much fun. Lots of challenges. And I like good challenges. Of course, I like the good challenge even more when I can figure it out, but sometimes just playing the game is fun enough. Alright, let's see if we've escaped our no bass hell. Alright, it's powering on, that's always a good sign. And
I'm having trouble connecting to the internet.
that's more like
For more
it.
info, check the Home app.
Goodness. Alright. So we've got all 3 HomePods finally fixed up here. Not sure how 2 amplifier boards decided to suddenly have no more bass. That's very interesting. I'm very puzzled. So let's take a quick look at those other ones, those other amplifier boards really quick. So we're creeping into after hours now. Let's see here. So this is their other pod here. Let's take a deeper dive. See if we can't figure out why this stopped having bass. If I can figure out why one of these 2 amplifier boards suddenly lost their bass, I'll be happy for the day. Alright, so the woofer's plugged in. I don't see any reason for this to be not working. So we'll set that back over to the side. Did I like bump something with my screwdriver? Putting it back together and like short something out? What's the deal here? Alright, what's the dealio? I just don't see any reason for this to not work. So let's get a power supply put back on. Let's just test this right here on the bench. Hook up a known good subwoofer. Let's check out the DC offset again if it's got any. It shouldn't because we went ahead and repaired that. Logic board and then power. Alright, what do we got here? So it's booting up. Huh. No base. Hmm. Huh. All right. Well, at least we've got everybody's HomePods fixed up and ready to go back home. These are going to require some more time, and unfortunately it's starting to get pretty late, so we're going to have to call it quits for now. But we've got ourselves 2 amplifiers with no bass anymore, so we've got quite a bit of work for ourselves here in the next few days. So go ahead and subscribe if you haven't already, so you can be notified as soon as I go live with my next live stream repair. If we don't have any more HomePods coming in over the next few days, maybe we can just do a straight stream for these mystery amps here that just suddenly lost their bass. In any case, I would like to get to the bottom of this, but I just not sure if I've got all the time in the world right now. Things are pretty hectic right now, but I can still manage to squeeze out a few HomePod repairs a day. So, all right, not quite the satisfactory result that I was hoping for today, but at least we are able to get people working HomePods sent back home to them. So, hope you all enjoyed this live stream repair, and I'll catch you all in the next one.